4 into 2, that is plus or minus 2 root 2. So the value of x is equal to plus or minus 2 root 2. If I transpose this determinant, the value of the matrix determinant will remain the same. If 2 rows and 2 columns of a determinant are interchanged, the value of a determinant changes in sign. If any 2 rows or 2 columns of a determinant are same, then the value of a determinant is always equal to 0. This is very important property. Hello dear students, welcome to this session of determinant class. In this session I am going to discuss regarding few problems as well as the properties of determinants. Very important is properties of determinants. We are going to study around 7-8 properties, and you will get one question from this for 3 marks. Otherwise the problems based on the properties of determinant. Now in this session of determinants, I am going to discuss regarding the problems which I did in the previous classes regarding expansion of 2 rows and 2 columns, 3 rows and 3 columns determinant, and also the properties of determinants. So properties with proof and the problems based on those properties. Usually you will get one question for 4 marks from this type of properties, and also 1 mark questions from this determinants. Now let us solve for 1 mark question. Find the value of x if this is given 2 into 4, just multiply this row and this row. So 2 into 1 is 2, minus 5 4s are 20 is equal to 2x into x is 2x square, and 6 4s are 24. So this is minus 18 is equal to 2x square minus 24. So just transfer minus 18 minus 24 to this side, plus 24 is equal to 2x square. So what is this equal to? 24 minus 18 is 6 is equal to 2x square. So x square is equal to 6 divided by 2, that is equal to 3. Therefore, the value of x is equal to root 3. So you can write x is equal to plus or minus root 3. The value of x is equal to plus or minus root 3. So this is how we are going to solve for 1 marker. Let us take a similar problem based on this concept. Let us take this problem. Find the value of x if x to 18 x is equal to 6 to 18 6. Now solve. X into x is x square minus 18 2s are 36. Again this is 6 6 are 36, minus 18 into 2 is 36. So this is x square minus 36 is equal to 0. X square is equal to 36. X is equal to square root of 36 is plus or minus 6. So x is equal to plus or minus 6 is the value of this determinant. Right. Now it's very simple. X into x, x square 36 is equal to 36 minus 36, 0. X square is equal to 36. X is equal to square of 36 is plus or minus 6. Otherwise you can also write, since these two secondary diagonal elements are equal, so therefore the value of x is definitely equal to 6. Straight away you can write the answer. Now let us take this problem, a similar type problem for 1 mark. So find the value of x if 3x x1 is equal to 3 2 4 1. 3 into 1 is 3 minus x square, 3 1s are 3 minus 4 2s are 8. 3 minus x square, transfer this, minus 3 plus 8 is equal to 0. Minus 3 plus 3 gets cancelled. So what you will get? Minus x square plus 8 is equal to 0, or just transfer this, x square is equal to plus 8, x is equal to root of plus 8. This can be written as, simplify this, 4 into 2, this is nothing but plus or minus 2 root 2. So the value of x is equal to plus or minus 2 root 2. This is the value of x. Very simple. So 3 into 1 is 3 minus x square. 3 1s are 3 minus 4 2s are 8. So transfer this. 3 minus x square minus 3 minus 8 becomes plus 8. Minus 3 plus 3 gets cancelled. Minus x square is equal to 8. Or transfer right to the left hand side. X square is equal to plus 8. X is equal to root of 8 is nothing but 4 into 2, that is plus or minus 2 root 2. So the value of x is equal to plus or minus 2 root 2. Now let us come to the properties of determinants. This is very important. So you will get one question for 4 marks. So from this we are going to expect one question from 4 marks, either the problems or the properties. So usually you will get this question in your part E section, that is 6 plus 4 mark. 4 marker question will be from the properties of determinants. Now let us consider the first property. What is the first property? The value of the determinant remains unchanged, remains the same, it won't changes, remains the same. The value of a determinant remains unchanged, remains the same if its rows and columns are interchanged. If I transpose this determinant, the value of the matrix determinant will remain the same. The value of a determinant remains the same if its rows and columns are interchanged. If it is transposed, then the value will remain the same. Now let us consider the proof. Let us consider, for example, let A is equal to consider a 3 rows 3 column determinant A1, A2, A3, B1, B2, B3, C1, C2 and C3. Let me expand this, plus, minus and plus. Now this is equal to, as I told in the previous class, the expansion of 3 rows 3 columns. Take A1, delete the row and column containing A1, this row and column is deleted, it reduces to 2 rows 2 column. Expand this, B2 into C3 minus C2 into B3. Okay, minus second element, minus A2 into same, delete the row and column containing A2, this is gone and this is gone. B1, B3, C1, C2 cross multiplied, B1, C3, this is B1, C3 minus B1, C3 minus C1, B3. Next, plus third element A3 into, delete the row and column containing A3, this is gone, B1, C2 minus C1, B2, B1, C2 minus C1, B2. Now expand this, that's all. So if I expand this, what you are going to get? A1, B2, C3 minus A1, C2, B3. So A1, C2, B3 again minus, so here A2, B1, C3, A2, B1, C3 minus into minus plus A2, C1, B3. I will take 1, 2, 3 as the reference, C1, A2 and B3. Next, plus B1, C2 into A3 can be written as B1, C2 and A3 minus C1, B2 and A3. Let us represent this as equation number 1. So listen here. So expand with respect to first row A1, A2, A3, A1, this row and column is gone. Just multiply B1, C3 minus C2, B3 minus A2 into, delete the row and column containing this, B1, C3 minus C1, B3 plus A3 into B1, C2 minus C1, B2. Expand this. So A1 into B2, C3, I will consider the bases 1, 2, 3, A1, B2, C3 minus A1, C2, B3 minus again A2, B1, C3 can be written as B1, A2, C3 minus into minus plus A2, C1, B3 can be written as C1, A2 and B3. Again A3, B1, C2 can be written as B1, C2, A3 minus A3, C1, B2 can be written as C1, B2, A3. Let us represent this as equation number 1. On the other hand, let us come to the second part. Now what is to prove? Delta dash is also equal to the same value. Now let us come to the second part. Right hand side, delta dash or delta 1 is equal to interchanging the rows. Interchanging the rows means first row becomes first column. This is A1, A2, A3, B1, B2, B3, C1, C2 and C3. Expand with respect to first row. So A1, B1, C1. So this is equal to A1 into, delete the row and column containing A1, B2, C3 minus B3, C2 minus B1 into, delete the row and column containing this, A2, C3 minus A3, C2 plus C1 into, this row and column is gone, A2, B3 minus A3 into B2. Expand this, that's all. So if I expand this, A1, B2, C3 minus A1, that is A1, C2 and B3. 1, 2, 3, 1, 2, 3. Again minus B1, A2, C3 minus into minus plus B1, C2, A3. Again plus C1, A2, B3 minus C1, B2, A3. Let us represent this as equation number 2. Now from 1 and 2, from previous equation and this equation, let us come to the previous equation. So that is, so here see A1, B2, C3 plus minus A1, C2, B3. Similarly here A1, B2, C3 minus A1, C2, B3. So whatever the values in equation number 1, we have the same values in equation number 2. Therefore, from 1 and 2, I can say that LHS is equal to RHS. Therefore, delta dash is also equal to delta, or delta is also equal to delta 1. That means the value of a determinant is not altered whenever its rows and columns are interchanged. When the rows and columns are interchanged, the value of a determinant will remain the same. Now, let us take an example. So, let us take an example. If A is a square matrix of any order, here 3 rows, 3 columns, then the determinant of A is equal to determinant of A dash. That is the property. That is, A dash is the transpose of A. Suppose if I interchange the rows to column, then I will get the same answer. So let us expand this. So plus, minus and plus, expand this. So 2 into 0 minus 5 4s are 20, minus into minus plus 3 into, delete the row and column containing this, 6 into 7, 42, minus 1 into 4 is equal to 4, plus 5 into, this is gone, 6 5s are 30, minus 1 into 0 is 0. So this is equal to 2 into minus 20 plus 3 into minus 46, yes, plus 5 into 30, that is equal to minus 40 minus 46, 6 3s are 18, 1, 4 3s are 12 and 12 plus 1 is 13, 138 plus 5 into 3, 5 3s are 50, 150. So this is equal to, so 150 minus 40 is 110, 110 minus 138. So that is equal to 28. The answer is equal to minus 28. So the value of this determinant is 28. Okay, interchanging the determinant. So if I interchange delta 1 or delta dash, interchanging the rows. So this is 2 minus 3, 5, 6, 0, 4, 1, 5 and minus 7. So according to the definition, the value of this determinant is also equal to minus 28. Let us verify this. So this is equal to 2 into 0 minus 5 4s are 20, minus 6 into, this is gone, minus into minus plus 7 3s are 21, minus 5 5s are 25, plus 1 into, this is gone, 3 4s are 12, minus 5 into 0 is equal to 0. This is 2 into minus 20, minus 6 into minus 4, plus 1 into 12. So this is equal to minus 40. 20 into 2 is minus 40, minus into minus plus, 6 4s are 24, minus into plus, this is plus 12. So this is equal to minus 40, 12 minus 12 is 12. So this is equal to 40 minus 12 is equal to minus 28. So the value of determinant, so determinant of A is also equal to determinant of A dash. That means determinant A is also equal to determinant of A dash. The value of a determinant will remain the same whenever the columns and rows are interchanged. In case of columns also, we are going to get the same result. Now, this is an example. Now, let us come to the property number 2, second property. What is the property number 2? If any two rows or columns of a determinant are interchanged, then the sign of the determinant changes. The sign, the value of a determinant changes in its sign. Actually, the meaning of the statement is if any two rows or column, any two rows or two columns of a determinant are interchanged, then the value of a determinant changes in its sign. The value of a determinant changes in sign. Suppose if you get positive, then after interchanging two rows to column, it will reduce us to negative. Suppose if it is negative means, then the answer will reduce us to positive. So if two rows and two columns are interchanged, then the value of a determinant changes in its sign. Now let us verify this. Let us consider let delta is equal to this. Now come to the proof. Now let us simplify this. Okay, this is plus, minus and plus. Now A1 into, this is gone as usual in the first property, B2 C3 minus C2 B3 minus A2 into, this is gone, B1 C3 minus C1 B3 plus A3 into B1 C2 minus C1 B2. Now expand this. If I expand this, what I will get? So let me take A, B, C as the base. A1 B2 C3 minus A1 B3 C2 minus, so A2 B1 C3 minus into minus plus A2 B3 C1 plus A3 B1 C2 minus A3 B2 C1. Let us represent this as equation number 1. So what is equation number 1? This is equation number 1. Expand this. B1 C2 minus C2 B1 minus A2 into B1 C3 minus C1 B3 plus A3 into B1 C2 minus C1 B3 C1 B2. So A1 B2 C3 minus A1 B3 C1 multiply by this A2 B1 C3 minus into minus plus A2 B3 C1 again plus A3 B1 C2 minus into plus, it is minus A3 C1 into A3 B2 into C1. This is equation number 1. Now let us come to the second part. Now here let second part RHS delta dash or delta 1 is equal to interchanging the two rows. So we are going to interchange first and second. R1 interchanges to R2, right? So here I will write B1 B2 B3 A1 A2 A3 C1 C2 C3. Now according to the definition, the value of delta 1 is equal to minus delta. Simplify this. Plus, minus and plus. So it is B1 into A2 C3 minus C2 A3 minus B2 into, this is gone, A1 C3 minus C1 A3 plus B3 into A1 C2 minus C1 into A2. So this is equal to, simplify this, A2 B1 C3 minus A3 B1 C2 minus A1 B2 C3 minus into minus plus C1 A3 B2 can be written as A3 B2 C1 again plus B3 A1 C2 can be written as A1 B3 C2 plus into minus minus B3 C1 A2 can be written as A2 B3 C1. Let us represent this as equation number 2. Now from 1 and 2, verify from 1 and 2, from equation number 1 and 2. See here, for first equation, A2 B1 C3 minus A3 B1 C3 in equation number. So in the previous equation number 1, A1 B2 C3 it is positive. So observe this, A1 B2 C3 it is positive. Here A1 B2 C3, see it is negative. There it is positive, here it is negative. Similarly, come to this minus A1 B3 C2, A1 B3 C2, A1 B3 C2, see it is positive. So wherever there is negative sign, we have positive here. So therefore from 1 and 2, I can say that delta dash is equal to minus delta. So The value of a determinant changes in its sign whenever its two rows and two columns are interchanged. This is very important property. So I will give the example for this also. So this property can be denoted as R1 interchanges R2 or interchanging C1 and C2. The same concept we have used for finding the inverse using elementary row operation in previous chapter, that is in matrices and determinants. And same concept we are going to use to evaluate the problems on properties of a determinant. So if we interchange any two rows, any two columns, we can that can be represented or denoted as symbolic representation R1 interchanges R2, C1 interchanges C2, or interchanging the R1 and R2 can be represented like this. Now let us take an example. Let us take an example for this. Suppose if I will take one example for this example. Let us take this example. If A is equal to 1, 2, minus 1, 2, 0, 1, 3, minus 1 and 2. Let us find out the value of this determinant. Determinant of A is equal to determinant 1, 2, minus 1. This is the matrix. So 2, 0, 1, 3, minus 1 and 2. Simplify this. So this is 1 into 0 minus 2 is 2. Minus into minus plus 1, minus 2 into, this is gone, 2 2s are 4, minus 3, minus 1 into, minus 2, minus 0. So this is 1 into 1, minus 2 into 1, minus 1 into minus 2. This is 1, minus 2, minus into minus plus 2. So plus 2 minus 2 gets cancelled, this is 1. So the value of determinant is equal to plus 1. Now according to the property, let us interchanging first and second, interchanging row 1 and row 2. Let me interchange column. So that is, call it as delta 1. Interchanging first and second row. So this 2, 0, 1 and first row becomes second row 1, 2 and minus 1. So second row changes to first and first changes to, and the third row will remain the same, 3, minus 1 and 2. According to the definition, if any two rows and two columns are interchanged, then the value of the determinant changes in its sign. So what is the answer? Here it is. So what is the answer you are going to get is delta 1 is equal to minus 1. Let us verify this, whether we will get minus 1 or not. Now expand this, plus, minus and plus. So 2 into, this is gone, 2 2s are 4, minus into minus, plus into minus, minus 1, minus 0 into any number is 0 you will get, plus 1 into 1 1s are 1, minus 3 2s are 6. So this is 2 into 4 minus 1 is 3, minus 0 plus 1 into 7. So this is 2 3s are 6, minus 7. 6 minus 7 is equal to minus 1. Delta 1 is equal to minus 1. So delta 1 is equal to minus 1. That means if you interchange any two rows and two columns, the value of a determinant changes in its sign. That is regarding the second property is concerned. Now come to the third property. Property number 3. What is property number 3? If any two rows, listen here, if any two rows or two columns of a determinant are identical, same, if any two rows or two columns of a determinant are same, then the value of a determinant is always equal to 0. This is very important property. If two rows and two columns are same, straight away you can put the value of determinant is equal to 0. No need of expansion, no need to expand. According to property, if two rows and two columns are same, therefore the value of a determinant is 0. You can straight away write. See here. What is given? Let us take the proof. So A1, A2, A3, B1, B2, B3 and B1, B2, B3. According to the statement, here these two are same. Second and third. Second row and third row are same. These two rows are same. Then according to the definition, the value of determinant is equal to 0. Now to prove that the value of determinant, to prove that delta is equal to 0. Since two rows, second and third row are same, therefore the value of determinant is 0. Listen, if any two rows or two columns of a determinant are same, then the value of a determinant is 0. Now let us consider delta is equal to A1, A2, A3, B1, B2, B3, again B1, B2, B3. Since these two rows are same, then according to the definition, the value of the determinant is equal to 0. Verify this. Let us come to the proof. So LHS, come to the proof. delta is equal to, so expand this, plus, minus and plus. A1 into B1 C2 B2 B3 minus B2 B3 minus A2 into, this is gone, B1 B3 B1 B3 B1 B3 minus B1 B3 plus A3 into, this is gone, B1 B2 B1 B2. What happens? All the elements inside the bracket are same. A1 into B1 B2 B1 B2 B3 gets cancelled 0 minus A2 into B1 B3 B1 B3 gets cancelled 0 plus A3 into these two gets cancelled 0. Any number into 0, this is equal to 0, your RHS. So that is, if two rows and two columns of a determinant are identical or same, then the value of a determinant is always equal to 0. Very simple. Suppose if you get this question, consider 3 rows 3 columns like this and simplify. So you will get the answer for this as 0. Now let us take an example based on this. Let us take one example. I will take one example. Example for this. Let yes, A is equal to matrix A is equal to 1 2 3 1 2 3 0 1 minus 1. So determinant of this is equal to determinant 1 2 3 1 2 3 0 1 minus 1. According to the definition, since these two rows are same, the value of determinant is equal to 0. First and second row are same, therefore the value of the determinant is equal to 0. Now let us verify this. Plus, minus and plus. 1 into 2 1s are 2, minus 1 3s are 3, minus 2 into, this is gone. Well, yes, this row is gone. Minus 1 minus 0, plus 3 into, this is gone. Well, yes, 1 1s are 1 minus 0. 1 into minus 5, minus 2 into minus 1, plus 3 into 1. So minus 5, minus into minus plus 2, plus 3 1s are 3. This is minus 5 plus 5 is equal to 0. So there is no need to expand this, since you know the property. Since if you know the property, straight away you can write the value of this determinant is equal to 0 because first and second row are same. Even if you know this, suppose one more example I will take. Determinant 1 3 2 0 1 5, again 1 3 2. The value of this determinant is also equal to 0 because first column and third column are same. If I expand, I will get the same answer. If you want, you can verify. 1 into 1 2s are 2, minus 5 3s are 15, minus 0 into number is 0, plus 1 into 5 3s are 15, minus 2 1s are 2. This is minus 13, 0 plus 1 into 13. This is minus 13 plus 13. This is equal to 0. So, if two rows, two columns are same, then the value of determinant is 0. Either it may be row or column. Now, I will take one more problem. Let us take evaluate. In the examination, they may ask evaluate or prove that the value of this determinant. Let me take this problem. 102, 18, 36, then 1, 3, 4, again 17, 3 and 6. So evaluate or prove that the value of this determinant, prove that the value of determinant is equal to 0. Now very simple concept here, just observe carefully LHS, the given determinant. So this can be written as LHS, I will write here, LHS 102, 18, 36, 1, 3, 4, 17, 3 and 6 as it is. Let me write here. Now, you just factorize this. Check 102, 18 and 36 are the factors of 6. So, this 102 can also be written as, 102 can be written as, this is the factor of 36, 6 into 17. Again, this is 6 3s are 18, 6 6 are 36. 1, 3, 4 same. This is 17, 3, 6 as it is. So, you can remove 6 as the common factor. If I remove 6 as the common factor, you will get 17, 3 and 6. This is 1, 3 and 4 as it is. Again 17, 3, 6 as it is. This is equal to 6 into. According to the property, if 2 rows and 2 columns are same, see first row and third row are same, then the value of determinant is 0. 6 into 0 is equal to 0. That's all. So you should have to verify. So this, since it is the fact, it is the multiples of 6, 6 into 17, 6 into 3, 6 into 6, you can remove 6 common factor, you will get 17, 3, 6, 1, 3, 4, again 17, 3, 6, 2 rows are same, therefore the value of the determinant is equal to 0. So that's regarding the properties of determinant. So we have studied only 3 properties. Still there are 3 or more properties. So that is, if all the elements in a row or column are zeros, then the value of a determinant is equal to 0. Or if all the elements above or below the principal diagonal are 0, then the value of a determinant is equal to product of the principal diagonal elements. Or this property, that is, if any row or column is multiplied by a constant k, then the whole determinant is multiplied by that constant k. And the last one, if any row or column contains the sum of 2 elements, if any row or column contains sum of 2 elements, then the whole determinant can be expressed as sum of 2 individual determinants. These are again 4 properties we are going to study. So that we will see in the next session. Thank you.